Hey, nice shirt, Alex.
Yeah, I mean, you guess you have the same. Come on,
That's right.
but yours very well too. So
I'm still waiting for my K8ssandra shirt, though. I mean, this needs to happen. We're
yeah,
working on it.
yeah,
We are
yeah, yeah,
working
yeah,
on
yeah, yeah,
this.
yeah, yeah. Oh yeah, finally. So YouTube gives us green light, and we are going live. So now, as we stream onto different platforms, I need to understand if you see us and hear us well enough. So if you hear me, hello, I'm Alex. And if you hear Jeff, hey Jeff, say a word.
Hello. Good day to you all.
Yeah, so if you hear us and see us on YouTube, set something on YouTube chat, set the thumbs up, and same for Zoom, and I will check it both, and we will be able to proceed.
Yeah.
We don't hear Jeff. I can hear and see
Hmm.
you all. Cannot hear Jeff. Okay, so give me a moment. Pum 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 pum. Yes, that may happen. So, and I had here as well. And you know what? I will stop virtual camera and okay. You know what? If you unmute yourself in Zoom, I think we will be fine, Jeff.
Okay, I'm gonna unmute in Zoom.
Yep.
All right, here we go.
Yes.
How does it sound?
So now you must be hearing Jeff as well. And now it
Okay.
works. Perfect, 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 perfect. Sounds great. Works well. I'm sorry for a little delay, but it's really hard as we are streaming at the same moment of time in Zoom, YouTube, and we even have a third plan B or plan C, you name it, which is Twitch, DataStax developers. So we are streaming simultaneously on 3 different platforms. Yeah.
Is the video on YouTube working?
Video on
Was the last
YouTube.
question.
Video on YouTube must be working. I mean,
Okay, they said they can see us now. I
yeah,
think maybe the video is just a little bit more, it might be a little few seconds behind on YouTube, which I don't think is a big deal. You see it when you see it.
yeah, exactly.
It's live to you.
Yep, good. So we can hear both of us on YouTube. We can see, hopefully, both of us in Zoom. I hope so. And I guess we are about to start.
All right, we can do it.
Yep. So, welcome everyone. I'm Aleksandr VOLOCHNEV, developer advocate at DataStax, and that's Jeff Carpenter, incredible Cassandra expert, and we are here today to talk about K8ssandra. So, Jeff, it's your turn now.
All right, well, I'm going to advance the slides and get going. Let's introduce ourselves, Alex. So why don't you go first?
Yeah, so that's, from my point of view, always the most boring slide of every presentation. People here not to watch to me, but people here to learn something new about Cassandra, databases, data on Kubernetes, and so on. So I'm a developer advocate at DataStax, and my job to help developers succeed with distributed systems, and first of all, Apache Cassandra. And it ain't easy because distributed systems never were easy. But we did a lot actually to make it as easy for you as possible running K8ssandra.
Awesome. I'm also working at DataStax as a developer advocate. I did do the O'Reilly book on Cassandra, the definitive guide. That's on its third edition now. So a lot of people will know me from that, and been giving workshops like this with you for quite a while, Alex. So let's get into it. Here's our rough outline for the workshop today. We're going to do a little setup at the beginning. We're going to talk about why we think now it's time for data on Kubernetes, why running a database on Kubernetes is a real thing that you should be thinking about. We're going to talk about why we think Cassandra is a good choice. And then we're just going to go through a lot of steps of working through this K8ssandra. You're going to install K8ssandra and get your own running Cassandra cluster. We're going to do some fun things to it, like kill a node and watch it get replaced or restarted. We're going to scale up and down. We're going to access some data. We're going to do some ops stuff. It's going to be pretty exciting. Lots of hands-on exercises. And we'll walk you through it. Now, we're also offering a badge of completion for this workshop that you can use to kind of brag that you've made it through the 3-hour workshop. So, Alex, why don't you tell us how this works?
Yeah, so the general idea is you put a lot of efforts learning new things, you do a lot of practice steps, and you listen to me, to Jeff, and so on and so forth. So my idea is to make you not only capable of doing things with data in the cloud, but also, well, not only in the cloud, maybe you're using your own data center. I don't care, it works good for both. But to make you able to brag about it on LinkedIn, because you know what? It never hurts to get some more money for the knowledge you learn it. You work on your own, so it's, well, time to get some confirmation for that. So for everyone who attends this workshop, learns the things, and do the practice steps, and submit the screenshots of his or her work, we will issue some upgrade complete certificate of completion, shareable, verifiable, so you can put it on your LinkedIn. I think you should, and enjoy not only knowledge but the benefits of the knowledge.
Awesome. And will they reach out to you directly for that? Who do they reach out to?
So the easiest way to do it is to simply open this github.com/K8ssandra/workshop, and you will have this issue. So like GitHub issues, and there is a button to create a new one based on the template. But basically, it's explained in the wiki, and there is a direct link. So as long as you can reach this K8ssandra/workshop wiki, you will find this button to submit your work.
Okay. Well, thank you for that, and we do encourage you to complete some of this work on your own. So you may be able to complete the steps or most of the steps in the live workshop. You may end up having some things to finish up on your own. Both of them are fine. And Alex is looking at a couple more issues with the streaming. I think we're mostly there with the quality and the audio and the video and the slides. Thanks for your patience. I feel like the internet was maybe just not ready for us, you know, and the massive volume of interest from all of you.
Yeah, indeed.
Maybe sometimes the little hamster wheels that run the internet take a while to get going too.
Mm-hmm.
That's just a little humor for you. Sorry. All right. So for everyone that registered for this workshop, we have sent you some reminder emails. So I hope that what I'm sharing with you here is mostly things that you already know, but I do want to highlight a couple more things. So Alex has already referenced the GitHub repo that we are using. So this is the github.com/K8ssandra/workshop. Now the instructions that you'll be going through are in that wiki that's on the workshop. So just add a /wiki to the end and you'll get to the workshop instructions for the step-by-step. We did give an opportunity for those that want to run the exercises beforehand. I'm sorry, that you want to run it. If you want to run the exercises on cloud infrastructure that we provide, we did provide those instructions in an email. And if you had requested infrastructure, you should have received an email with your login information, right? Is that correct, Alex?
Yeah. So there are, first of all, you need to, if you can't use your own infrastructure. Oh, so stop. First of all,
Yeah.
it looks like we have a little stream issue direction host to YouTube. It's fine in Zoom, but for YouTube, I want to reconnect and restart the stream. It means what for YouTube, we will hold on for a second because I have to reconnect. Stream will look frozen to you. It's completely fine. Don't worry. We will get back to you in a moment. So I'm stop streaming for YouTube and we will reconnect in 20 seconds. Don't go away. We get back. Okay, now it looks fine to me. And we are streaming again. And mostly probably YouTube connection must be good. I don't know what goes wrong with YouTube today. So, stream is healthy, is connection quality excellent. Finally, I hope it will stay like that.
Excellent.
Yep. So we can proceed.
Excellent.
Yeah, okay. let's keep it excellent. So we will get back to the infrastructure question. So you have two ways to do the practice. So basically you have three ways to do the practice. First step is do not do the practice, and it's obviously wrong. Yeah, I mean like that.
Right.
Second point, you can do practice using your own Kubernetes cluster. And it doesn't matter, you can go with GKE, you can go with AWS Kubernetes services, you can host it with your Minikube or Kind or whatever you prefer. It really doesn't matter. It's completely platform agnostic, well, as long as you run it on Kubernetes, of course. That's KubeCon after all. And the third option, if you cannot use your own infra, you can use our infra. From one point of view, it's cool because, well, you get a free training node in the cloud. It's amazing. So thanks, DataStax. But from another point of view, we have a lot of people at this conference. So we cannot afford running them for too long. They will be terminated after 24 hours. So you need to have some hurry in this case. When there are two options, or you already filled the form, I guess it's in your email, or right. Second case, you if not fill it, then go and fill it right now. I will dispatch some more notes in 10 minutes. Second point, if you filled this form already but didn't receive this email, that's completely fine, because sometimes it takes some time for a mail to reach you. So check your spam folder, and I will check all the emails dispatched. And if you will not give it in like 20 minutes, half an hour, I will check it and send it to you again. So please don't worry, you will get your instance if you want it. You will get it, nothing to worry about. So I believe I've answered the question, Jeff. What do you think?
Yeah, no, that's perfect. The other couple of items to mention on this slide that we're looking at now is there are different ways to interact with us during the workshop. If you are watching on Zoom, you can type your question in Zoom chat, and we have ourselves and our team hanging out there. If you are watching the YouTube stream and want to interact in that chat, you can interact there. And then best of all really is to join our community Discord server, because that will be live and available post-workshop as well. So the K8ssandra community on Discord is also available. And we'll be showing you how you can get engaged and interact with the community in a longer setting than just this workshop, which we really want. We want to encourage an ongoing conversation with you all. There is a lot for all of us to learn, and that includes Alex and myself, especially. And we want to hear from you. And then, of course, you can check out our Twitter feed at K8ssandra. All right, so those are kind of the few high-level ways to connect with us.
Yep.
So if you haven't been already, the GitHub page has the wiki under the K8ssandra workshop on GitHub. That has the instructions that we'll be going through. Thanks to a friend of the community who already has been going through some of this stuff before the workshop this morning and filed an issue, found a bug. that I had injected at the last minute. Yes, I'm not perfect. So anyway, that's perfect. I love the interaction. And yeah, if you haven't been to this page, this is where the exercises will be. Now make sure that if you're doing a local installation, you want to make sure that you're running on a machine that has enough power in it, and that you're already going to need a local distribution like Kind or K3D or something like that. You'll want to make sure that that's up and running, and there's some instructions there to make sure that you have the proper storage class installed as kind of a prerequisite. Those are really the only minor steps. And then one more thing. So the instructions for the exercises are written in such a way that you need to plug in your address wherever you see this your address kind of in the brackets here. You'll need to substitute that in. If you are using one of the cloud instances that Alex is spinning up, that will be the IP address that you need to plug in there. If you're running locally, it'll just be localhost. So just know that. We try to make the instructions generic so that you can run things and correctly access your K8ssandra cluster, whether it's local or running on a cloud instance. Anything that you'd add to that, Alex?
Not really. You explained it all very clear.
Okay, cool. All right, thank you. All right, I think it's time to get going. We want to get to know you a little bit. So one way that we do that is to do a little Menti quiz here at the beginning. We want to understand what your background is, what you're kind of bringing to the table this morning, so to speak, or this afternoon. I'm going to keep saying it's morning, even though most of you, it's probably just rolling into evening. So you'll have to forgive me. But let's get going with the quiz, Alex.
Yep. So now you see the Menti quiz. And how do you join that? Very easy. You just go to menti.com. Mostly probably with your mobile phone, it's the most convenient way, and enter the code 53745586. You see it at the screen. Or you can simply scan the QR code next to Jeff, and you will be good. So, and first answer is available already. What's your experience with Cassandra? So once again, menti.com and use this code 53745586. It's in the top middle of the screen. Good. So I see we have some people with understanding, people using it regularly, not too much, and people with no prior experience. That's completely fine. We will explain you some very short basics. We have to respect those who already have experience, but we will say a couple of words about that. Well then, next question. What is your experience with Docker? Well, I've heard this morning it was a KubeCon, so I expect some knowledge. And no one never heard about. Okay, we have two persons who never heard about it. Amazing. So that may be a rough ride for you because we do not cover Docker and Kubernetes basics. We don't. That's a KubeCon after all, so let's put some requirements. What do you think, Jeff?
Yeah. I mean, we do have some learning materials on the DataStax/dev site. So there is actually an online course that you can take there that walks you through basics of running Cassandra in Docker containers, and then it builds up step by step to the point where you're running K8ssandra. And we will provide a link to where you can find that course. Somebody who's listening maybe can drop that. One of our friends here at DataStax can drop that in the chat. I'm also going to tell you about it toward the end of the workshop.
Yep. So let's proceed then. What's your experience with Kubernetes?
Now it gets real.
Yeah, things got real now. We have Kubernetes rockstars. Of course, we have. And if you don't have experience with Kubernetes, don't worry, it's fine. Again, we don't explain basics, but if you're at the KubeCon, you mostly probably understand some things already. So we are good to go. Then, and that's it for now. Now, Jeff, that's your turn, and I'm switching the screen to you. But don't close Menti. Don't close Menti because we will run a game, a quiz very soon, and you will be able to win some prizes from DataStax. From real prizes shipped worldwide. And well, I love when DataStax prizes are shipped worldwide, sometimes to very, very hidden places of the earth. That's always amazing and that makes us happy. So,
Yes, we've seen some, I've mailed some things to quite a variety of places over the years, and
yeah,
amazingly
absolutely.
they get there. Okay, so we're gonna dive into kind of our first big content section here, and I just want to give a little bit of a big picture, not a lot. We're gonna start drilling down pretty fast, don't worry. But we have been on this journey, those of us that are working in IT industry, toward this idea of moving workloads to the cloud. And what is a cloud native application? What does it look like? And at a very high level, I've at least started to think about this problem space in terms of we have some infrastructure that we're running on, maybe like infrastructure as a service. I'm using someone's cloud to give me compute, network, and storage. On top of that, we are kind of building up our own data infrastructure on top of that, and then at the highest level we're building applications. A lot of these are microservice based applications. We're trying to build by 12-factor app principles, or principles of having these small loosely coupled microservices, and things are happy, right? So at a high level we have an architectural approach that we think works. Now we're coming from a world, the point where we started from is not cloud aware. It's not cloud native. So unless you've only recently kind of come into the IT industry, you're probably familiar with the world in which we were running our own on-premises data centers, or maybe renting space at a colo where we had all of our racks of equipment, and we were keeping these data centers up ourselves, and deploying, provisioning, all of that. We were running legacy databases. Maybe as we got a bigger and bigger amount of data, we bought a bigger and bigger box to put that database on. And then we were building these monolithic applications. And again, it was really hard to scale these. About 15 years ago, we started seeing this cloud computing infrastructure that AWS and others were providing. We started seeing NoSQL databases like Cassandra come into play. That these were technologies that allowed us to take advantage of highly scalable compute infrastructure. So we started this journey of gradually moving some of our workload up to the cloud. And a lot of times we were in this hybrid situation. I know when I was my previous position before DataStax, I was working as an enterprise architect at Choice Hotels, and we had a hybrid architecture that we were working to at the time. New microservices in the cloud, talking back to legacy systems running in the on-premises data center. So we definitely had kind of a, as you do when you're partway through this migration to the cloud, a mixed architecture of old technology that had been around for years, new workloads running in the cloud with a mixture of data solutions. So microservices talking to databases that we had ported. Maybe we could run some MySQL databases that we just kind of drop in, replace in the cloud. And that worked okay for small amounts of data. We were spinning up Cassandra clusters as well, and running and managing those ourselves in the cloud. And then in some cases, we were doing things like using a database service that was provided by one of the cloud providers. So you're probably in this world, or at least familiar with this kind of situation yourself, where you have this hybrid architecture. You've seen this in practice, right, Alex?
Yep, absolutely.
Okay, so I think as Kubernetes has matured over these past few years, we started moving our microservices tier into Kubernetes, and this is no problem, right? Kubernetes is designed for stateless workloads. It does great. It scales it like crazy. But some people started asking this crazy question like, hey, well, can I run my database there? And there's a lot of high profile heavy hitters in the Kubernetes community that for years have been saying it's not quite ready. Maybe not yet. So, but fortunately, there's been a number of people, organizations that have been driving innovation in this area, and we really think this is becoming a possibility to do. So the ideal is, yes, I have this microservice-based architecture. I'm running the either single node or distributed databases underneath that, all on top of a Kubernetes engine that's running on top of whatever infrastructure I've got, right? Well, okay, so we're not actually doing that yet, though. Let's say we might be in the situation where we're going to run most of it in Kubernetes, and so we're kind of back to this mixed architectural situation again, where we have all these microservices. Some of them are running against data infrastructure that's hosted in Kubernetes, and some of it is running against data infrastructure that's not hosted in Kubernetes, and maybe there's a little bit of database as a service mixed in. This is kind of the reality, the transition that we see a lot of people making at this point. So ideally, we would like to get to a world where it's just microservices running on top of data infrastructure, and all of that hosted on top of a single Kubernetes environment, or at least one Kubernetes environment per data center that we're running in. And then there's one final problem that we've seen people run into, which is even if they are able to get a database running and deployed into Kubernetes, they tend to have duplicative infrastructure and management pieces, all the DevOps stuff that we need. So your monitoring stack. We've seen a lot of companies that have a monitoring stack for applications and then a separate monitoring stack for databases. And they're, in many cases, they're even running the same software, like multiple instances of Prometheus and Grafana, for example. So one of the things that we're trying to do with the K8ssandra project actually is to bring all that together. So integrated in terms of running everything on Kubernetes, integrated in terms of having one observability stack and one management stack. This is the goal. And we hope that what we're showing you today with K8ssandra is something that's going to take you many steps down the road toward realizing that dream, right? Single observability stack across the whole deployed suite. Okay, there's a great article. If you're still kind of skeptical about this idea of running a database on Kubernetes, I recommend this article from Chris Bradford. He's one of our colleagues. It's a really well-written article and a great story about how he is one of the converted now. Highly skeptical at first of running a database on Kubernetes, and he walks through his journey about how he got there to the point of being ready to do this. So yep. It's an article on the news stack. You see the URL there. It's a pretty easy article to find. Maybe somebody could do me a favor and drop a link in the chat if you've got it, because I'm going to keep rolling.
Yeah, I want to say
please, yeah, go ahead.
I want to say a word on it, because I also was very skeptical about this idea. If you are with me, at least with me, old me, previous me, you definitely have to read this article. It's not easy to persuade people working with infrastructure. You know why, Jeff?
Tell me.
Why? Because they trust no one. If they are good experts, they trust no one. And it takes a while to learn what some things have changed. But some things indeed have changed.
Prove it.
Yep.
Oh, absolutely. You have to prove it. You can't just take someone's word for it. You got to test it out. I'm not asking you to take something on blind faith here, but I'm saying this is time. There's another data point in reference to this databases on Kubernetes is a thing, is the Data on Kubernetes Day that we had yesterday. There's a whole community that is now part of the CNCF, Cloud Native Computing Foundation, that is the Data on Kubernetes community. So it's actually dok.community. As a precursor to KubeCon, we hosted a whole day yesterday with talks from multiple different companies, practitioners, people building out use cases of running data on Kubernetes. There was a talk on Spark, running Spark on Kubernetes. So there's a lot of material out there and a lot of people working very hard toward this. So this is another community we would encourage you to get involved with if you have interest. Okay. I so badly want to get to the point where we're hands on keyboards touching a lab. I think we're pretty close.
Yep, and meanwhile, I've seen some more people send their emails and requested the training note. So I'm sending to all the new people who just registered for a training instance, I'm sending them to you right now.
Perfect. All right, so K8ssandra, the goal of this project is to provide a scalable data tier that is as drop-in usable as possible with minimum amount of thinking required to get the configuration. The basic idea of this is that it is Cassandra deployed on Kubernetes, and it's a whole ecosystem such that all the pieces that you would need to have a running and well-maintained Cassandra cluster are provided for you. We, just in time for KubeCon, have redesigned and relaunched our K8ssandra.io website. So we're going to tell you about the pieces and parts that are in K8ssandra. But really the best way to learn kind of on an ongoing basis is to go to the website. You can sign up to join the community. You can join the forums to ask questions. We have a regular flow of blog content, and including like a lot of tutorial, hands-on step-by-step stuff that we're adding there all the time. So that it's really a great place to get involved. Our first exercise is we are going to set up K8ssandra, and Alex is kind of do the walkthrough demo of this.
Yep. So give me a moment. I'm switching to my screen, and first thing I want to say is actually just a second. So I have to switch from Jeff's screen to my screen. We want experience for those workshops to be really like in the old school conference style, so we want to have multiple speakers. Okay, now we are good, and you must be seeing my screen. Yeah, looks like you
right
can
on.
see
Looks
my
good.
Screen. Yep. So as said, Jeff, sorry, but I will repeat. There are two ways: local and our cloud, and you have to execute some preparations if you are doing local. They explain it here downstairs. So first step, if you are doing local, install missing software step. If you are using cloud node provider, check what you can connect to it. Now I'm going to connect to it, obviously. I already did that, but I want to show you how do you do it. You've received a link, or will receive in a minute, with your username and password and link to your instance. You just can open it. That's the main page. Oops, that's the main page of the training instance, and it has links to the materials, and it has links to the tools we are going to install today and use today with K8ssandra. So I click on this link, your SSH console in a browser, and I get this page. So when I get this page, actually I want to open it again, so I will, oh no, okay, it's fine. You put username yesi2-user and password, you receive it in the email, and you are right here. So what do we have here? kubectl get nodes, and we already have cluster. It's cluster deployed with kind. So if you don't like the idea of bash in browser like I do, you can completely good to go with your terminal. So you can connect the SSH yesi2-user, add then a link to your cluster, and have fun in terminal. I'm going to stick to this one, and I will make it a little bit bigger so you will see things we are going to do.
Thank you for old man like me. That's really helpful.
Yeah, good. So that is our instance, and let's start with setting up K8ssandra. It's really easy. So it's so easy what actually I'm enjoying this step. Thanks to Helm, we're using Helm, and Helm is a package manager for Kubernetes. Not exactly package manager, but it behaves like apt-get or yum, so we call it package manager. And first step I do is to add repository for K8ssandra, like you would do with apt-get, for example. With apt, you can add something to your repositories. Done. Now I will need one more tool, which is Traffic. Traffic is an ingress for Kubernetes because we are going to work with tools installed in our cluster. You will need to have access to that. And we don't want to use port forwarding, so we will use ingress. We prepared everything for you. If you have no prior experience with Traffic, it doesn't matter. It's very easy, and I will show you what to do, and it's well explained in the wiki of the GitHub project. Then, and if you are curious, I'm using all the time Nginx. I don't want to use Traffic as an ingress. Answer is you are good to go. Batteries are included, but swappable. So you can put your own ingress or no ingress if you don't need it. That's completely fine. Now, as I've added those repositories, I need to update Helm with the command helm repo update. Very easy. Boom. So what it says me, successfully got an update from the Traffic and Cassandra chart repositories. Update complete. Happy helming. Thank you, Helm. That's the plan for today. And first thing I'm going to do is I'm going to install our ingress, which will allow us to work with K8ssandra from external connections. So command is very simple. I ask Helm to install by the name Traffic with a configuration file Traffic YAML. And name is Traffic is deployed, namespace default, deployed revision 1. So we are all good. Now I can say watch kubectl get pods. How does that look? Okay, Traffic is starts. Nice.
Perfect.
Yeah, it will be operational in a moment. And meanwhile, let's take a look at the Traffic YAML. You people are usually curious about the configuration files. So Traffic YAML file is very simple. It just defines some port mappings. As it's only for educational purposes, but not production deployment, we are using kind, and therefore we are mapping proper ports to a ports of a kind, of a Docker, of a localhost, so we will be able to connect to it. Cool. And yeah, service type is node port. Well then, how it goes with my Traffic? Traffic is running. So how could we check that? Very easy. We have a link here, link number 5, K8ssandra ingress Traffic. And it says install first. If you will try to open this link without installing ingress, you will get an error, of course. But we did the job well, we installed ingress. So we have, so that's like an ingress controller, router, but with a nice dashboard so we can see what's going on. We have some routers, services, no middlewares, we don't need them, and they work together so we can open a router and see what it routes to which site. Nothing too much here right now because only Traffic is running, so those all are internal Traffic things. Now we are ready to proceed to the next step. The next step is going to be installing of K8ssandra. Now, well, please do not forget, most of the people forget about that. We have to adjust some settings on your cluster to be your specific. So I'm getting my link, this workshop, workstation, blah, 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 KubeCon, datastackstraining.com. You have something similar. And I open this file, which is going to be, so first I want to clear that. And then I open file K8ssandra YAML. And there are some things to change. First thing I want to change is the Reaper address. We will discuss Reaper in details afterwards. So, but that's needed for routing, and I have to remove those things for sure. Now it looks better. Now the same for Prometheus. Boom. Okay, and finally the same for Grafana. Pum, 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 pum. Okay, boom. Looks good to me. Now we can finally deploy K8ssandra. So How does that go to me? Same command like we did already. Helm install -f file of configurations, name of the deployment, not deployment like Kubernetes deployment, but I mean in general I have to call it somehow. Yeah, and K8ssandra to specify what exactly we are deploying. I push the enter button and we have to wait for a moment because now Helm has, well, pretty a lot of work to do. But you know what? It's work for Helm to do, not for you to do. So I'm fine about that. It's going to release control in some seconds, so I will be able to show you what's going on in this file. So you will know what exactly we are installing. Or you know what? I actually will not wait, but switch to this file located in this K8ssandra workshop. So you will see it at your place as well. What do we define here? First, we define Cassandra settings, which version we are going to use, 3.11, and we are getting ready to be able to deploy 4.0 very soon, so that's very high in our priority, and mostly probably we will support already release candidates very soon. But for sure,
we're going to talk about that in a bit.
Okay, then storage class is a very important thing. It's explained in the documentation. If you are using your own instance, you should check and read through the local setup installation because storage class matters. Then some settings for Cassandra. I will not talk too much about that. And then finally data centers. So the main entity you operate with in K8ssandra is Cassandra Data Center. It's a custom resource definition we use to simplify operations on Cassandra. In this case, we are going to have single data center, size of 1, so only one instance, and it will have one rack named default. When we have Stargate, which is a special topic, and Jeff will show it to you soon, or well, explain it to you soon. Reaper, to maintain repairs, to maintain consistency, to avoid anti-entropy, to maintain anti-entropy services. And QPrometheus stack with Prometheus and Grafana, obviously, to have Grafana and Kubernetes to monitor our stack. So I guess I'm good to go already. Yeah, so K8ssandra deployed. Let's take a look what's going on under the hood. Watch, oops, kubectl get pods. Okay, so a lot of things happening here. First of all, Cas operator. It's the Kubernetes operator which is responsible for Cassandra, quite obvious. It's running already and it's good. Now we have data center 1 default stateful set 0. It's the first node of Cassandra. It has internally 2 containers, one for Cassandra as it is and one for API management. And now API management is running and Cassandra is being started. It takes a little bit longer time to start. Then Stargate again later. Grafana is running already. QPrometheus operator to monitor, to control monitoring stack. Reaper operator for repairs, and Prometheus and traffic, but you've seen that already. And we can see what stateful set 0 is running and fully operational. So, so far so good. How can we verify installation? How we can see the status of the things going on inside? First,
yeah, we should do that.
Definitely. First, kubectl get, and now as I installed Cas operator and K8ssandra, I have a new entity called Cassandra Data Center, and therefore I can ask kubectl to get Cassandra data centers. And I have one. Isn't that amazing? And now I can say therefore Cassandra kubectl describe Cassandra Data Center DC1. And while that's plenty a lot of information, well, you know, that's Kubernetes in the end, and we have pretty a lot of things here. So what really matters to us is we see what that's Cassandra Data Center name 1, DC1 namespace default, as we asked. For that, some more annotations, kinds, metadata we may need to know about that, and some more things. So cluster name will be K8ssandra. Configuration comes from Cassandra YAML as follows. and so on and so forth. And in the end, we can see some changes, what happened, some events happened. And then, so we created resource service, Cassandra DC1 service, seed service to work as a seed node, DC1 all pods service, stateful set, Cassandra, K8ssandra, DC1 default stateful sets, scaling up rag default, and so on and so forth. And of course, we have created super user for us to be able to work with K8ssandra. So, Jeff?
Yes, we did it.
Yeah.
We have a successful install.
Yep. So now I'm switching back to Jeff, but don't close your console. If you are doing it with me, you are good to go to do it later. We will answer your questions in our Discord chat. So don't be afraid to be too late. And I'm switching to Jeff. Boom, Jeff, your turn.
All right. Okay, so we have just done, Alex has demonstrated a very simple K8ssandra installation, and he did what we would call probably more of a development installation. We do support and do encourage you maybe for your first K8ssandra install to do that on your desktop if you feel like doing that, as long as you have the required CPU and memory configurations. So we deploy this all the time on Kind or K3D or Minikube, and that works fine. More likely for a real production deployment, you're obviously going to want to run on a real Kubernetes engine that's designed for production, like GKE or AKS or EKS. One of the things that is that we've announced this week is the ability to run on any of these Kubernetes engines. It's not that you couldn't run K8ssandra on them before, it's just that you would have had to do a little bit more work yourself to determine what is the right class of compute instances, what are the storage particulars of deploying on this platform. We've actually got that all baked out for you now. So if you go to the K8ssandra site, you can find the documentation about running on GKE or on Amazon, and I think Azure, we're polishing up the last few little details there, and that will be available very soon. So these pre-canned configurations for your Kubernetes engine of choice, this is yet another place where we're at removing complexity, adding simplicity, making more of this just like a one-button push kind of deployment, or I guess not one button push, but one command line action. So that's what we're pushing toward, making this as easy as possible. If you want to go back and look through some of these installation options, again, we've just done a local install for this workshop. If you go to docs.k8ssandra.io/install, you'll see these instructions for GKE and the Amazon Kubernetes service, and that's where the Azure instructions will show up as well. So what we're trying to do with K8ssandra is provide a highly scalable data tier. What we're doing is, on top of your given Kubernetes infrastructure to be able to deploy Cassandra, and we're doing that in stateful sets per data center. There's a Kubernetes stateful set. And then the configuration of K8ssandra out of the box also comes with Stargate, which is a data gateway that provides multiple APIs on top of Cassandra so that you can do REST interactions, or there's a GraphQL API that's been made available. We're going to demonstrate some of these APIs later on. This is a major productivity booster for application development teams. So it's not necessarily required that they learn the Cassandra query language in order to start working with a really scalable data tier. So this is a major win. And we'll walk you through some of the details. So Alex has given you the command line view of what's in the box, of what is inside K8ssandra. I'll just review the ingredients here, kind of a more graphical or a conceptual way. So depending on how your mind works better, you'll get a sense of what all these pieces are. So the core is Cassandra, scalable cloud native database. On top of that, we're layering Stargate. And then we will, Alex has shown how we've configured traffic to provide external access to these APIs from outside the Kubernetes cluster. You don't need ingress if your microservices are running alongside K8ssandra inside a K8ssandra deployment, but we'd like to show you how to do this ingress with traffic. Behind the scenes, we have some tooling in the form of Cassandra Reaper and Cassandra Reaper and Cassandra Medusa. These are two open source projects that have been started by the Last Pickle and Spotify over the years to provide additional capabilities for operating Cassandra at scale. Repair in particular is one of those operations that can be performance intensive, and so Cassandra itself does not come with like built-in settings about how to run repair. That's really something that you have to answer for your own environment and what's going to work best for you. So Reaper provides scheduling of repairs, and we'll demonstrate that toward the end of the workshop. And then backup and restore is again, this is largely driven by your own practices for how you handle backup and restore within your environment. What are your policies for that? So Medusa is a tool that helps you automate those backups. So this is all baked into to the K8ssandra distribution. These two power add tools that a lot of people find very convenient for working with Cassandra. And then we've provided, we're using the QPrometheus stack and integrated that alongside Cassandra in your K8ssandra distribution. And so that provides metrics aggregation and visualization. And the great thing about this is because it's Prometheus compatible, if you already have your own Prometheus and Grafana stack that you're using for application metrics, you can disable the one that comes with K8ssandra and just direct things to work with your existing. So you don't have that duplicative observability stack. You can have a unified observability stack. And then, of course, we're using Helm to package all this up and to deliver it. So that's what's inside the box. If you want to think about this in terms of what does my day-to-day interaction look like with K8ssandra, I'm going to use Helm to deploy K8ssandra into the Kubernetes cluster. That's going to cause the deployment of Cassandra, Stargate, Prometheus, and Grafana, the tools, Reaper, and Medusa. And then I'm set up for my development teams to come in, and they're going to code. Maybe they're developing web and mobile apps that are running on our user devices. So those are going to need to kind of access our services perhaps through an ingress. Once we're kind of inside the Kubernetes cluster, we have microservices that may be accessing either directly into Cassandra or through Stargate as a data gateway. And then as we're doing this, as Cassandra is running, its metrics are being shipped into Prometheus so that an operator can then come in later and view and visualize the metrics of what's going on in the cluster through Grafana. And they can also perform operational tasks like scheduling and verifying that repairs are taking place through Reaper and performing backups. You can really back up to any S3 compatible storage. So S3, MinIO, we're going to talk a little bit more about what those options are for storing your backups. All right, so I've been talking about this idea of having a single observability stack, and Alex is actually going to show you what that looks like right now. So we're gonna, so I'll just real quick, you're gonna see these user interfaces that look like this here in a second. We have deployed the QPrometheus stack. This is one of the great things about Helm charts, by the way, is we didn't have to do a bunch of work to integrate Prometheus and Grafana. We just grabbed another chart and included it in the K8ssandra chart. So with minimal configuration of the values to set them appropriately, we have this integrated really nicely with as part of K8ssandra. So that's how this works, Alex.
Yep. So give me a moment to switch to myself. Boom. Cool. So we have the same instance, and first of all I want to show you what as K8ssandra was installed. Now we have much more things in the traffic So we can see different routers and services available for literally everything what K8ssandra delivers to you. And we have a lot of things here now, much more than it was. And what's interesting to us, now we see here path prefix Grafana and path prefix Prometheus. That gives us a hint about the topic we are going to talk now. So, on the same main page, you may find the link, main page of your instance. You may find the links. First one is going to be Prometheus. And Prometheus is being installed, and metrics are already exported. So when I click on this, and oh yeah, okay. My computer is pretty busy. So we have a long list of different metrics exported and available. For example, I can take like a metrics collector for Apache Cassandra, histogram for percentile 75. And I can execute that and get it as just logs output, metrics collected, but I also can switch to graph and see them, visualize it, and see them results of that on a graph. Not perfect results, but it's a training instance with a lot of things going on inside. But you know what? Why do we use graph in Prometheus if we can have something much better? What means much better? Much better for me is Grafana. Grafana is an incredible tool for data visualization. Don't consider it as just as monitoring and alerting tool. It's wrong, but it's something much more important. It has, a ability to visualize basically everything you want to visualize. Okay. And at this point, we may have already some dashboards here. So we have things like Cassandra cluster condensed with limited information per cluster. So not like limited, it's a wrong word, but condensed information well about the cluster. How many requests served? What's the coordinator P95 latency? What's the table P95 latency per cluster, and so on, so the most important things. And besides that, that's not only about the metrics you have here, but as we prepare it variables, you can, if you have multiple clusters, you may group by cluster. You can specify which cluster you want to use. I have only one, so now it doesn't make much sense, but yeah, that's doable. For the suitable data center, you want to use also per rack, per key space table, and which particular percentile is most interesting for you right now. And I've pushed this button for P99, and now it's switched to P99 latency, if that's what matters to you. Same thing goes for K8ssandra, overview in general. So here I will have some more data per cluster, error for outputs, write latencies, node statuses, node counts and histories, cluster data size, SS table counts, and so on and so forth, getting into pretty deep of the Cassandra internals with hinted handoffs, active compactions, and so on and so forth. So, and it's all full already, and literally I did nothing special to install that. I just did helm install K8ssandra. And it's all prepared already. Can you do it on your own? Sure you can. Should you? That's completely different question. So that was about quick monitoring overview for K8ssandra. Do you want maybe to say something on that, Jeff?
Yeah, I think, we could switch back over to the slides.
Give me a second. Boom, you are live.
All right. I think, there's really, I don't know that there is a lot more to say about the QPrometheus stack right now. We definitely dive into a lot of metrics, but I think we should talk a little bit more about Cassandra.
Yep.
Now, my screen is not updating on Zoom. Am I laggy?
Maybe. Give me a second. Maybe you could, for which slide are you showing right now?
The Cassandra introduction slide.
Yeah, so Apache Cassandra NoSQL distributed database. At my
There we
site,
go.
it looks good. Let me check.
Okay.
Let me check. On YouTube, it looks good.
Okay.
And in Zoom, what's about Zoom? Okay, Zoom slide looks good to me.
Okay.
So we are good.
Yeah. All right. Sounds great. Just wanted to make sure. So we think that Cassandra is a really great database for deployment and running on Kubernetes. It has a lot of the same principles behind it. So a lot of these cloud native principles, having a shared nothing kind of architecture in which every node in a Cassandra cluster is the same. There's no one node that's any more powerful than any of the others. So Cassandra has been around for a while. It became an Apache project officially at the top level in 2010. We are now about to have the Cassandra 4.0 release. There is a release candidate out. So what we're working with today in our exercises is Cassandra 3.11 because that is the official latest stable release according to the community. We're getting super close with this Cassandra 4.0 release candidate. So our plan is for the K8ssandra 1.2 release for that to be on Cassandra 4.0. And that'll be either the release candidate or if 4.0 has gone GA by the time we do that K8ssandra 1.2 release, it would be that. So this is just a matter of timing. Cassandra as an architecture is a distributed database. You run multiple nodes of it. The nodes are smart enough to know how to coordinate with each other. So they distribute your data across the nodes and store multiple replicas. Your queries are super fast because the nodes collaborate in order to answer them. To get additional scale in a Cassandra cluster, you just add additional nodes, or you can remove nodes if you no longer need that capacity. So you can scale up and scale down. Cassandra was designed so that if you lose a node, maybe it goes offline, maybe the infrastructure that it's running on gets killed or reclaimed or preempted, right, by something else. We can survive the loss of nodes in a Cassandra cluster and still have your data around. We also have something called tunable consistency. So if you're familiar with the CAP theorem and the idea of you can, in order to have your data in a distributed system and always have access to it, you're always making trade-offs, right? How much consistency do you require? How many nodes do we have to hear from in order to consider that a query or a write is successful? Cassandra has the ability for you to tune that. We're working with Stargate to make that something that you have to think about less, but it is a flexibility that Cassandra has. Its data model is a partitioned row store. So you access it through the Cassandra query language traditionally, and it looks like you're writing rows of data. So it is a somewhat familiar paradigm to what you might be used to from relational databases that use SQL. CQL is pretty similar, although there are some differences, which we can talk to briefly, and we've got tons of material for you to dive into that on DataStax Academy. So that's just a high-level overview of Cassandra. What Cassandra does to distribute your data is every table that you define a partition key, and that partition key is used to distribute the data out so that it's balanced across the different nodes that are in the cluster. This is a really trivial example that I'm showing on this slide in which a country code is used as a partition key. There's a lot that goes into Cassandra data modeling in terms of thinking carefully about the design of your keys so that data can be partitioned in a balanced way. But just understand that at a very high level, this is how it works. So data is allocated out to the different nodes based on a partition key that you define. And it's actually multiple copies of your data get stored to different nodes in a cluster. We have visualized what's called the token range of a Cassandra cluster on this slide. If you can imagine that the partition key values get hashed to a value that's somewhere between 1 and 100, the number on each of these nodes in the cluster represents the range of data that they own. So that black node at the top is responsible for 84, and then everything up to 0. I can hear you typing, Alex. I don't know if that will distract people, but so each of the nodes in this cluster has a range of hash values that it is the primary owner for. That determines what data that will be stored on that node. Now, if we have a replication factor of 3, meaning that 3 different copies of the data will be stored, each of the nodes in this Cassandra cluster will take on responsibility for 2 ranges. And if we get to the point of having 3 copies or a replication factor of 3, then actually each of the nodes in the cluster will be responsible for 3 of the token ranges. So there's an overlapping responsibility here, and the data gets spread across the cluster. You'll have 3 copies of all your data. That means if a node goes down, or even if 2 nodes go down, you'll still have access to the data that you need. So this is how Cassandra provides high availability. So when a piece of data gets written into Cassandra, it can be written to any node. The nodes are all aware of the topology of the cluster and who owns what data. If I write a row of data and its partition key hashes to, let's say, 59, then we have a replication factor of 3, and that is going to get routed to the 3 nodes that are responsible for owning that range of data. Now that's one way. The ring is one way to think about how a Cassandra cluster works. This actually gets mapped onto this concept of racks and data centers. So what I'm showing you here is a really simple Cassandra cluster. It has 6 nodes in it, and all of them are in a single data center in this particular design, and they're allocated across 3 racks. Now, historically, a rack might actually be a physical rack of equipment. When we're moving into cloud infrastructure, racks, and most importantly, Kubernetes, a rack might actually be a different Kubernetes worker node. So what I'm showing here is, this is kind of taking that conceptual mapping from the last slide and showing what this might actually look like in a Kubernetes cluster, where we have a single Kubernetes cluster. It has 3 worker nodes. Within it, 3 Kubernetes worker nodes. I'm sorry, there's 3 different failure zones or Cassandra data centers. There's actually 6 worker nodes, and we see here that each Cassandra node is running on a different Kubernetes worker node. We'll talk a little bit about the Cassandra operator or CAS operator, and it has these rules, these affinity rules within it that manage all the details. You don't have to worry about this when you're using CAS operator or K8ssandra. The details of how Cassandra nodes are mapped onto the Kubernetes worker nodes, that's all handled for you. Okay, so our next section is we want to dive into how Cassandra actually provides you high availability. I mentioned that you can survive the loss of a node, and it might look something like this. I get a piece of data that needs to be written into a cluster. In order to have a replication factor of 3, there might be 3 different nodes that are intended to store that data. Because that node was down, that blue node was down when I went to write to it previously, I couldn't write. So 2 of the nodes received the data, and then this orange node that received the original write is going to hold on a hint for the blue node. And then when the new node comes back online, the data will be written, and Cassandra will get itself back in sync so that all the nodes have the same data. So we're not going to lecture on this in detail here just due to time, but just this is meant to help provide an understanding that Cassandra has these internal mechanisms behind the scenes that it's working hard to keep the data in sync so that every single node in the Cassandra cluster has the same view of the data, and we can survive if a node goes offline for whatever reason. So we're actually going to do this in the K8ssandra way, or in a Kubernetes intensive way. So Alex is going to walk us through an exercise of actually killing a node and then watching it get replaced through the Kubernetes control plane and the operator that we provided. So take it away.
Yeah, that's my favorite part. So give me a moment to switch back to myself. And it's going to be this screen. Oh,
sorry.
Big display. Boom. Okay. So we have some things happening. We have like big issues coming to our cluster. First one, we need to break something and see how Cassandra will react on that. And what exactly going to happen? Okay, my console is here. Boom. So we have here a list of the pods. And you know what? Shit happens. If you live like me in the real world, some things will go wrong. Some power outages, some network issues. Network is getting lost, or which may be even worse, laggy. So how does Cassandra survive that? Very easy. So let me show you some things. Now we have this running and operational, and we are good to go. But now I'm going to issue this command to keep it clear. What's going on to happen? I'm going to ask kubectl, not K8ssandra, but just low-level direct operation. Quite unexpected. Cassandra, well, usually no one expects you go and kill your database live on production. Still happens. So I ask kubectl to delete pod K8ssandra DC1 default stateful set 0, so the first one and only node we have, and I'm going to do it quite like in a hard way with a grace period of 10. It's going to be a short time, so Cassandra node will have not enough time to close. Actually, I want it to be even more abrupt, and let's set it to 8, for example. Boom. And what I now want to say is watch kubectl get pods. And this node is being terminated, but it immediately goes to 0/2. It's like quite an abrupt exit. And immediately Cass operator notices that, and while I was talking, I didn't even have time to highlight for you what it came directly from termination to initialization. Now it's running. We have API management tool sidecar running, and Cassandra is being started, and it will be fine very soon. So basically as much time as it requires for your node to restart. And now we have had, of course, one node. And when you have one node, actually that's pretty funny. Jeff, I was asked about that a couple of times on the offline events, talking to people after conferences. What will happen if I have a cluster of 3 nodes and all 3 nodes are down? What will happen? And I'm like, what do you expect? Cassandra will answer? If you've lost all of your nodes, you will have no data. So I'm sorry.
This is where we get to the difference between, you know, a simple demonstration, and obviously you're running the smallest possible Cassandra cluster with just one node. Obviously, if you kill that, you have 0 availability while that's getting restarted. But that's not a real production deployment of Cassandra.
Yep. So if you have 0 servers left, you will be not able to access your data. There is no magic, no unicorns, a bit of rainbows, which is still good, which is still something. But if you have a ticket to a better world with unicorns and servers being able to answer, even then all of them are down, please send it to me. I would really need this one. So basically, that's how it goes. And if you would have, that's a funny point. If you would have not single node, but like you usually work with Cassandra, some of them, maybe at least 3, or maybe 300s, or maybe 3000s. I don't know the size of your business, but Cassandra is able to handle any size. So then basically you would never notice this shit happens, because you have no downtime as other nodes are reporting data and able to accept writes while single node is down. And then Cass operator restarts and joins all the required things, and your cluster is back and operational again, even then you have some nodes down during some period of time. Maybe it took about 1 minute, I guess. So Jeff, do you want to add something, or am I switching back to yours?
Yeah, let's switch back.
Boom, you got it.
Okay, so one of the things that I think is cool about running Cassandra in Kubernetes, we have when you install K8ssandra, you are actually using a custom Docker image that we have created. So there is there's a Kubernetes a Docker image that comes out with the Apache Cassandra project. We've created this special Docker container for K8ssandra that has Apache Cassandra plus the Cassandra management API. So this is an extension that we've provided. It's open source. It's working on being donated back to the Apache project. Right now, it's a separate API, and what it does is it exposes some management capabilities on top of a Cassandra node and provides a nice RESTful API. You can see a little bit of the Swagger documentation and what that looks like here. So we've got this integrated in K8ssandra. So the Cassandra nodes in the cluster are the Cassandra operator is reaching out and touching this management API on the Cassandra nodes, and it's using these readiness probes and liveliness probes. This is how Alex is able to show you that for example, that Cassandra node that we killed and it got restarted, the way that kubectl was able to say, oh, I see that this is initializing and now it's ready to go, that's because of these probes that we've installed on the Cassandra nodes alongside the backend Cassandra daemon. So anyway, this is a really Kubernetes native way to do this kind of monitoring and management, which I think is pretty cool. All right, so I've made a couple of mentions of the Cass operator and what it's doing. We want to really kind of dig into this here. This is one of the pieces of the real meat of the K8ssandra project. If you think about everything that it would take to get a Cassandra cluster, if you've ever looked at the Cassandra configuration file, you know that there are definitely a lot of options available. Some of them have to do with tuning the performance of the database. Some of them have to do with networking and helping the different nodes to understand where each node is located and how to talk to each other. If you were to try to build this up yourself to manually deploy a Cassandra cluster in Kubernetes, it's a lot of work. So one of the things that we're trying to promote is this idea that, just to say that you're going to run Cassandra on Kubernetes is not enough in itself. Your determination to do that, you need some tooling to kind of help you along the way. So if you were going to do this manually, the steps that are on the left here are the things that you would be wanting to think about: networking, storage, firewalls, actually installing Cassandra on nodes, installing your observability stack and getting that integrated so that Prometheus can actually connect to the nodes and grab their metrics. And then there's all these best practices for Cassandra operations. You need to have a backup strategy. You need to have a strategy for when you're going to run repairs, and et cetera, et cetera. So Cass operator is the encoding of all this business logic of how to deploy a Cassandra cluster in Kubernetes, how to have affinity set up correctly so that you get a single Cassandra node per Kubernetes worker node. All the smarts to know how to do that is really what's built into this KASS operator. So as you go to scale up a cluster, it's going to know how to talk to the Kubernetes scheduler to get the nodes allocated so they're evenly spread out. If you have to shrink your cluster, it's going to know which node should be killed and what's the best one to remove, et cetera, et cetera. So KASS operator is built on best practices that we have been talking about in the Cassandra community. Over the course of the past few years, there are multiple companies that have produced open source operators for Cassandra. We are working with them, and there's been a lot of crosstalk and interaction, and we're trying to take the best of all of that work that's been done previously and roll that into this KASS operator that's part of the K8ssandra project. But there's a vibrant community of people that are actively talking about the details of running Cassandra on Kubernetes in this SIG, which meets every other Thursday. And the meeting time rotates across time zones so that it's convenient for people. You can see all the past videos of these interactions on the Planet Cassandra YouTube channel. And I've put the link to the Apache project wiki where you can see the minutes and discussions of this Cassandra Kubernetes special interest group. So there's a great community of people interacting, asking all the hard questions, kicking the tires to really try to make this work well for everyone. One of the reasons that it's become possible to run databases on Kubernetes is the extensions. Kubernetes as an architecture that is based on APIs. It's very extensible, and so there have been some great things that have been coming to maturity over the past couple of years, like the API for persistent volumes, where you can create a piece of storage, give it to Kubernetes to manage through the persistent volume API. Each of those persistent volumes is of a well-defined storage class. If you went through the local installation option for the exercises, you may have seen a step where we want you to have a storage class that you can use for K8ssandra, and we have instructions about how you can use a really simple storage class that's provided by Rancher Labs, just for the purposes of demonstration. But that's the purpose of what that's all about, is telling your K8ssandra installation about some storage that can be allocated to the different Cassandra nodes. And this concept of a persistent volume claim is used within Cassandra, within K8ssandra and KASS operators, so that nodes can request, hey, I need a chunk of storage to put my data on. So these are the APIs that Kubernetes provides that make all of this possible. Another key API that we're relying on is the stateful set. So this is like a replica set, except it has the additional capability of having these persistent volume claims. And so we can have the idea of nodes that get restarted. Like, we know that in Kubernetes, when Alex went in and killed that Cassandra container, that container is gone forever, right? But Kubernetes is detecting that container is gone and creating a new container to replace it. And through the logic in KASS operator, it's being associated, basically a replacement container is being associated that connects to the same persistent storage that the original node had. So through these constructs of stateful sets, persistent volumes, persistent volume claims, we have the ability to maintain continuity of Cassandra nodes that are owning data storage that they should, without having to rebuild and restream data all over the place. Another piece that KASS operator is building on is this idea of the extensibility of Kubernetes, and that we can provide new APIs. So Kubernetes gives us the ability to build out custom resources. Like for KASS operator, we have the idea of a Cassandra data center. So you remember in the exercise where he was able to do a kubectl get Cassandra data centers. that's where we've extended the Kubernetes basic API with a Cassandra specific construct called a Cassandra data center. So this is a really powerful way for us to build additional capabilities on top of the basic Kubernetes paradigm. And if you actually look in K8ssandra and you get all of the resources, I think it's a kubectl get all resources, or it's something like that. And you can actually see the resources of different types. So we have CAS operator, which defines a Cassandra data center. We have the Medusa project, which actually is defining custom resources like a Cassandra backup and a Cassandra restore. And we're using other charts like the QPrometheus stack. And so they actually have some custom resources they define as well within that QPrometheus stack. So really powerful way to extend Kubernetes capabilities. And then the final piece that I'll talk about is that this idea of an operator. Now, an operator is not necessarily a resource in itself. It's basically just another container that you run within a Kubernetes cluster, but it participates in the Kubernetes control plane. So you write this business logic that understands how to interact with the state of, let's say, a Cassandra data center. So the CAS operator knows how to create Cassandra data centers. It knows how to monitor their state and perform maintenance operations on them. And this is how we extend the Kubernetes platform with custom operational knowledge, that instead of having a human operator that has to know and perform this, we have it encoded in a Kubernetes operator. So again, this is all within the paradigm of how Kubernetes works. The control loops in Kubernetes are all about monitoring state and then making changes, taking action to bring the state of the world into line with the state that we desire. All right, so I think we're about halfway through our time and we're about halfway through our content. So I think this is a great time to mix things up with a quiz.
Yep.
Alex is going to run for us. We're going to do a little knowledge check here and see how much you've learned so far.
Yes. So I'm going to switch back to my screen, and now game is about to start. Yes. So get back to Menti. I hope you have heard me and didn't close the page. But if you did, now jump back. The address is still the same, menti.com, and code 53745586. It's somewhere in the top middle of the screen. And if you prefer to use QR codes, that's a QR code for you. And now things got real. Now you have not just answer. You have to answer as fast as possible to get more points. And you have to give the right answers. If you give the right answers and answer fast enough, you will get on top of the leaderboard and you will win some prizes from DataStax. So I think we should proceed, and that's a good moment to start. I see 61 like here, which is great. 62. And I see we have a lot of attendees today. That's amazing. So I give you a few more moments to start. When quiz will start, like if you are too late, then it means you are too late and you will not able to answer the first question. That means what you will not get the points for the first question. 72, that's already something. And I think like last few seconds, and 331, 332, 333, and we start right now. So that's a question 1. Answer fast to get more points. What is K8ssandra? Cassandra with an integrated data lake. A MariaDB on Kubernetes deployment tool. Kubernetes native Cassandra with built-in operations tools, and the sister of K8ssandra. So,
There's always that funny answer, that one really funny one.
Yeah.
Yeah.
So, and what about the? It looks like no one was able to answer. What's wrong with Menti now? That's. You know what? Looks like I have to restart quiz because it looks like no results, no answers, and that means what Menti got stuck. And
Yeah,
I
that's what
have
I'm
to
seeing
restart
from
Menti.
our we got a bunch of our audience that's letting us know that that has happened.
Okay, so give me a moment to switch. And I want
Huh.
to restart Menti. I'm
Maybe
sorry.
we should be talking to Menti about
Yeah,
running on Cassandra, I guess.
yeah, we have to do it finally. Usually it works well, but sometimes it goes wrong. So sorry, we will have to start again. But now you maybe already know at least how it works.
Now you know the first answer too, so this is just like a race of thumbs,
Yeah,
right?
now it will be
Like,
only to answer quick. And finally, second attempt. Second attempt, and I'm starting countdown. So, answer fast to get more points. What is K8ssandra? Second attempt, second start. Cassandra with integrated data lake, MariaDB on Kubernetes deployment tool, Kubernetes native Cassandra with built-in operation tools, sister of K8ssandra. And you have 5 seconds left, but I see what the most of the attendees answered already. And now we have answers.
oh, it's working.
So first of all, good news, it's working. Then second of all, bad news, 5 people answered that's a Cassandra with an integrated data lake. Using K8ssandra, you may have Cassandra with a data lake using some additional tools we will speak, not exactly integrated, but you can, using for example Apache Pulsar, you can put your data to multiple storages at once, including data lake. But K8ssandra is definitely not a Cassandra with an integrated data lake. So let me see the leaderboard. And like there must be a very minor difference. Sangram Red was the fastest one with 997 points. It was like incredible performance. Very quick answer. When Maverick, Mayank Shabadi, Alex Serban is on the 4th and Casper on the 5th place. Congratulations, but it was only the first question. So let's move on. And I'm going to ask you next question. So answer fast to get more points. Ingress allows for communication to the internal Kubernetes from the outer world. True or false? Oh, people are answering so quickly. Just numbers.
Oh,
Boom, boom, boom,
wow.
boom, boom, boom. Yeah.
Yeah. Well, I mean, this is like it's either it's true or it's false. I mean, not as many options to think through here. Just what does your gut tell you?
Yeah, and the right answer was true. Correct is correct. Yes, it's indeed. Ingress allows external communications to the internal Kubernetes network. So, are there any big changes on the leaderboard? Who was the fastest quiz time? Like, again, very smooth line. People are giving answers very quickly, and Ayo was the fastest one, getting to the 3rd place. And then Mayank Shanabadi got to the 1st one, and Sangram was on the 2nd. And that's a very good result, but we still have some more questions.
We have a ways to go.
Yeah.
All is not lost.
So, and that's a question 3. So, answer fast to get more points. What is the Reaper? There is interesting story because most of you maybe have no experience with Reaper before, but we told you what is it and why you may need that. It's a backup and a restore tool, it's an anti-entropy tool, it's a data deletion tool, or it's a pretty green person. So, time is up, and most of you gave the wrong answer. So, Reaper is an anti-entropy tool. Reaper is not a backup restore tool. Backup restore tool is the another one, which we will explain in details later, but we discussed it today. So what's it is doing?
We're going to start to see some separation here on our leaderboard.
Yeah, now leaderboard will look differently because I bet there will be some mistakes. So just IO, sorry. Ion was the fastest one with Emre Basar using this mistake of many hours and getting directly to the second place. And then Jaya, sorry, I'm not sure how to read that right, gets to the third one. And my congratulations, very well done. And Aleksandr holds the fourth place. So stability is the sign of a master. Very good. Well then, I'm going to
What is the strategy here? Should you slow down and consider your answer carefully, or just fire away for speed? I'm interested to see.
For me, it's always about to find the balance. And question 4. So, answer fast to get more points. What is a Stargate? What is a Stargate? What is a Stargate as a component of a K8ssandra? Repair tool supporting Reaper, backup and restore tool, data gateway to upgrade your data API, or a TV series. Well, I mean, of course, the right answer is the fourth one. We know what Stargate is, a TV series. But in the context of K8ssandra, what is it? And most of you gave the right answer. Stargate is a data gateway, so you can maintain one database, but deliver 4 different APIs. As someone with operations experience, I'm really excited about that. If my developers want to have document API or REST API, I simply give them Stargate and I still have to maintain only one database, not a bunch of them. That's incredible. So, will there be changes, big changes on the leaderboard? Okay. IO was the fastest one, holding the first place, and Carolina moves Alex and gets to the fourth one. But there are no changes in the top 3.
Some movement. Okay.
Okay. So. Well, that's a question number 5. So answer fast to get more points. What is Helm? Package management tool for Kubernetes, drop-in replacement for Kubernetes, next generation database, Viking's Head. I think okay, so most of you gave the right answer. It's a package management tool for Kubernetes. It's not a drop-in replacement for Kubernetes, and it's definitely not a database. So again, too easy for you. No mistakes in the leaderboard. No one got 0 point. Anim was the fastest one, but that only helps him to stay on the 5th place. With Ayo, Emre, Jaya, and Carolina.
I'm watching this race for 3rd place is getting tight.
Yeah, but that's still very minor difference in points. For example, difference between 3rd place, 4,677, and 4th place, 4,661 is so minor. It's like 15 points. So that's just a couple of milliseconds from the...
It's like a beat of a beat of a butterfly's wings.
Exactly. And yeah, and that's just that separates price from no price place. Okay. So that's a question number 6, and we are getting close to the end, ladies and gentlemen. So answer fast to get more points. K8ssandra uses traffic as what? Dependency management tool, Kubernetes ingress, monitoring tool, air control service. Well, who knows, like you see different services evolves. Maybe moment will come then K8ssandra will be responsible for air control service as well. But the right answer is Traffic is a Kubernetes ingress, not a dependency management tool and not a monitoring tool. Although Traffic has pretty fancy dashboard to monitor the states, routes, and services indeed, but it's like very routing specific, it's not a monitoring tool. Good. So, how it goes? Leaderboard. Okay, so that was hard for GG. And it gets to the 10th place of the top 10.
Oh my goodness.
That's something.
It's a tie for third right now. Wow.
Yeah, exactly the same amount of points for Joao and Carolina. And Carolina was the fastest one today, so that's incredible. But no changes in top 3 yet. And that's going to be last question. So, warm up your fingers, watch at your phone, not on YouTube or Zoom, because those may introduce some delays. Watch your fingers, watch your handy, watch your mobile phone, and be ready to answer, because we are starting the last question which will decide everything right now. So, answer fast to get more points. What's the purpose of Grafana? Cluster management. It's a time series database. Data visualization. No purpose. Grafana is useless.
Oh, that's harsh.
Yeah. I mean,
And wrong.
as someone developing data source for Grafana, I feel like I was injured directly into my heart. Yes. So,
yeah.
Grafana is
so you got it right.
Yep. Grafana is a data visualization tool. And that is right answer. It's not a time series database and it's not for cluster management. So how it goes? Will there be changes? And it looks like yes. So K8ssandra was the fastest one, which led him to the 6th place. And Carolina, in the very last second, in the very last moment, gets over Joao with some, again, minor difference of like 20, 25 points, 24 points. And my congratulations go to Ayo, Emre Basar, Carolina, and actually Joao, because I believe Ayo was the winner for at our previous events, and therefore he cannot get the prize. I'm sorry, one prize per person. So I have good news for Joao. Make a screenshot of your screen. So winners, make the screenshots of your screens and send them to jack.fryer@datastacks.com. Yeah, and as Ion writes, he will skip the prize. It means what he gets the lead, but prizes go to Emre Basar, Carolina, and Joao. And congratulations.
Bragging rights is still a big deal, though.
Yeah.
We know.
Yes, so we are done with the main team. And you know what I will do actually right now? We still have some things to do. Don't quit. We still have some things to do. We still have some steps to show and demos to run. But to make you able to answer our questions already, if you have to quit earlier, for example, I will run the quick survey on Menti, and it will stay open during the whole during the whole workshop, what left of the workshop. And first of all, I kindly ask you to make your point on what do you think of this workshop. Have you enjoyed that? It must be a pretty quick answer. If you're still with us, you spent almost 2 hours with us, it means what you liked that. Thank you so much for the warm answers. And I have the next one, which is a bit more important. Any feedback? What do you want to say you liked the most, or what do you don't like so much? Maybe you would suggest us something. That's an open question. You can type your answer, and I will keep this window open during the next step, so you can type your feedback now or later. Workshop is not done. We have 1 more hour actually. So workshop is not done. Swag not being dispatched. We indeed got a problem with our logistics company. So Swag is being dispatched, first of all. And second of all, indeed, I'm very sorry for the delay with the prices from the previous workshops. I'm very sorry for that. Cool. So, and now I'm switching back to you, Jeff. What do you think?
Yeah, let's do it. Oh, I like that comment about let's demo a multi-node environment. We are actually, if you check out the YouTube channel, the DataStax developers YouTube channel, there are a couple of demos there that are a little bit more involved. If you want to see some more stuff, we'll put a link up at the end of the workshop. I'm sure you can find DataStax devs on YouTube, but we'll give you some information about that at the end as well.
Yep, and I'm sorry for stepping.
Yeah.
There is one feedback on Menti more hands-on. You know what? This workshop features 8 hands-on exercises, and we provide free cloud instances for you, and there is a huge fleet. So I don't know what else we can do to deliver more hands-on for real. 8 exercises.
How about the third hour of the workshop is almost all exercises? Let's
yeah,
go.
And basically that's what we are going to do. Yeah. So,
okay.
Yeah, sorry, I just was like, what do you mean more hands-on?
All right, you're gonna find out. Here's the secret decoder ring is that you're gonna have fewer slides from me and more command prompt from Alex. In fact, I have one slide here. And what I really want to say is, it's been demonstrated over the years that one of the best things about Cassandra is the fact that you get linear scale as you add capacities. So if you add nodes to a Cassandra cluster, you get an equivalent amount of growth. And other databases that use distributed principles don't always have that. A lot of times you get diminishing returns as you add additional nodes, but Cassandra's been demonstrated to scale linearly. And Alex is going to show us now what it looks like to scale a Cassandra cluster running in K8ssandra with basically just a single command.
Yep. And excuse me, I'm answering questions. Okay, I will answer questions later then. And I'm switching to scaling up and down. And actually, I think I will just scale up because it's exactly the same like scaling down, just changing the numbers. So, boom, 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 boom. Yes, here we go. And I'm switching to my screen. Yes. So, scaling with K8ssandra and Cassandra is very, very, very simple. What's the idea? Cassandra is very smart in understands your network topology. Doesn't matter if you run on a cloud with regions and availability zones, or if you run on data centers with servers and server racks, and it's still simple because Cassandra will take care of the allocation of the data over multiple racks, over multiple data centers. And basically, you don't have to waste your time taking care of the affinities and thinking, now, okay, this rack is busy, so I will put next replica to this one, and this one to, oh no, it's busy and it's fragile, bad reputation already, so I have to move it somewhere here. You don't have to take care of that. Cassandra takes care of that, and that's what I love. I'm very lazy, I love it, then the tool takes care of these routine operations for me. So, how it works? It works very, very easy. I open K8ssandra configuration file, and what I'm going to do is I'm going to data centers field of this file. So Cassandra, boom, 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 data centers, data center I work with. So DC1, I have only one now, and I specify size to 2. You can try using your system to switch to size 3. For the cloud instances, those a bit limited in size, it may be not perfect experience, let's say. So I will stick to 2, although it's not let's say, the default recommended size. For production, we usually speak about another amount of servers. So that's enough. I'm storing this one. And next instruction I have to give is to basically to upgrade the deployment. So upgrading the deployment idea is very, very, very easy. I'm getting to Helm and putting command of Helm upgrade. Upgrade what? K8ssandra, using which charts K8ssandra with a configuration file. I've just modified K8ssandra.yaml. Then Helm applies this upgrade. It will be a second revision of the same system deployed. And we can see, yeah, so we can see what status deployed revision 2, second revision. And now we can say watch kubectl get pods. And something interesting is happening. We can see what this K8ssandra DC1 default stateful set 1 already. So we have stateful set 0 and we have stateful set 1, which is the second node. And first one is still running and second one is being initialized. So it will take some time for it to start. From my experience, usually it takes around 1 minute, but it of course depends on your hardware. In this case, we are using pretty cheap servers with hard disk drives. So for your production, mostly probably it will be significantly faster. And after that, I'm going to show you one more interesting thing. While it's being upscaled, how to downscale it? Exactly the same way. You go to a configuration file, you set up like which amount of servers you need right now, you say Helm upgrade, and Helm will apply proper changes. Well, or better to say, it will ask K8ssandra, so CAS operator, to apply proper changes. Going to be pretty simple, as you see. And first node is running. That's the API management tool. And therefore, second one is going to be available also very quickly. Meanwhile, it's being started. I want to show you something. I want to show you some more information about that. Yes, very well. So now notice a thing. There is a stateful set 0, so first server. It runs on worker 2. And now take a look at the stateful set 1. It runs on the worker 1. And that is not a coincidence, but a plan, the part of a plan. In K8ssandra, it will consider different workers, for example, as racks, and trying to put replicas as far away from each other as it's possible, because server racks or worker nodes tend to fail together. Again, it's fully automated. You don't have to care about that. That's already done by our engineers. And let me take a look how it goes. So maybe we already done. Yep. So looks like system is not satisfied about this first one. It wants to replace that. I don't know what went wrong, but it's okay. It will take care of that in background, decommission it and bring it back new. Actually, I will later take a look at what's wrong with this one stateful set. We will see it soon running. Jeff, I want to skip downscaling part because it just makes no sense. Exactly the same operation.
Yeah, that's fine.
Good. And that means I'm switching back to your screen.
We can leave that part for people to do on their own.
Yeah, definitely.
It's kind of fun. All right. So I feel like a little badly, we haven't given a lot of love to our developer friends so far. Most of what we've been talking about is operations, but if you are more of an application developer type, or you want to help sell this idea of running to your applications team, let's talk about working with some data. So We are going to use Stargate, and I'm going to talk about that. First, I thought maybe, Alex, you could walk us through an exercise where we use the Cassandra query language, use CQL. This is the traditional way to interact with Cassandra.
Yes, definitely. So, okay, it completely makes sense. Then let me switch back.
Yeah.
I just switched. Okay. And I'm getting to working the data exercise, and that's going to be my screen then. Well. So what do we have here? We are going to work with the data a little bit. And usually when we work with Cassandra, we think of two different approaches. Or, well, not different approaches, but different ways to reach data. In first one, we use simply Cassandra query language and Cassandra query language shell to communicate using SQL to Cassandra and get queries. And second one, we using drivers. So we access Cassandra programmatically from our applications using a normal base like the most used. And that's what we are going to do today, is we are going to do both. First thing, to communicate with Cassandra, we will need to know password and username. By default, K8ssandra creates a user called K8ssandra super user, and I'm going to open this secret and grab some data. So what is it inside? kubectl get secret. I hope you know what's going on here. Then which secret I'm going to use, so K8ssandra super user. Then I will need output JSON path data username. So I will need username, and then I decode it to get the answer decoded already. And as I told you, answer is K8ssandra super user. It goes the same with the password. So I'm basically replace username. Okay, that was again about don't use bash in browser, but not a big deal. Command is exactly the same. I just replace username with password, and that's my password. Very well. So what do we do next to that? We have password, we have username. I'm going to work with data a little bit. And to work with data, that's all good, but I want to work first using SQL. I have to connect to the node responsible for K8ssandra. So, to bot, sorry. My first command will be looking like that. I'm going to execute kubectl exec -it K8ssandra dc1 default stateful set 0, so the first Cassandra node. Container I'm going to connect, call it Cassandra, as it's a pod containing multiple containers, so it contains 2 and it can contain more, if as you will see soon when for some more advanced scenarios. So that's enough for me. K8ssandra Cassandra -/CQLSH. CQLSH is the one, so it looks now wrong. You know what? Actually, we'll make it easier. I will first connect to bash. Sorry. Okay. Now it's clear. Yes. And now I will connect to CQLSH. So my user is going to be K8ssandra super user.
So you got an extra Q in there.
Yep. And my password will be this one as specified. Boom. Boom. Oh, that's a typo. CQLSH. Sweet. So finally we connected to Cassandra using CQLSH. And now we can work with Cassandra to check some things. So I can, for example, ask to describe key spaces. Okay, we have some, we can describe tables for a key space. So I can, for example, say I use ReaperDB and describe tables and see some tables inside and so on and so forth. So this approach is a little bit like straightforward. You need it very often to debug some things. But what I want to have better is to use some programmatic access, the APIs. And my way to do it will be to work with PetClinic application. If you have a Java background, you have heard about that mostly probably. It's a demo application being used to show like different technologies, different approaches, and so on and so forth. And we have this one as well here. So I will clear. I want to show you this file. Oh, okay, I have to quit this node first. Yep, so PetClinic YAML. That's a pretty simple one. So we are going to have some deployments here. First deployment will be PetClinic backend. Pretty obvious, so it will use our image data stack /devs PetClinic-backend K8ssandra. And of course it has Cassandra user, Cassandra password from secret, and some more settings like use K8ssandra DC1 service and so on and so forth. Second, and we generate a service to be able to communicate via ingress with PetClinic backend. Then second deployment for frontend, therefore service for frontend, and the ingress configuration, so we will be able to work with them. PetClinic backend. Now I'm going to apply this one, so kubectl apply -f. It's going to be petclinic.yaml. It will go pretty quickly, so backend will take some time to start, but usually it's pretty quick, and frontend is running already for sure. So we can watch for our kubectl get pods. We can watch for our pods. We see what backend and frontend in the container created state. Okay, so it's okay running. So right on time, perfect. Now I want to see how it goes at my site. So I go here. First, I want to check on K8ssandra ingress. So traffic. Do we have more things now? Yes, we have already 12 routers and 12 services. Very well. And now I get to PetClinic demo application. PetClinic demo application is like a very simple pet clinic management tool, you can say. Features owners, veterinarians, pet types, and so on. And we can, okay, so finally it's loaded. We see, so this data is being loaded from a database as specialities. And we can see some veterinarians and so on. And so I can go on and create a pet, for example. Which pet would you like to have, Jeff?
I would like to have a rabbit.
A rabbit. Okay. We don't have a rabbit yet, so we have to create a new one. Jeff wants to have a rabbit, and it's done. And now we can pretty easily go back to the previous one. Connect to K8ssandra. We can take a look at our describe key spaces. Oops, my bad. It should be desk or describe. And now we have Spring PetClinic key space. So we can quite easily use Spring PetClinic and therefore show table, describe tables, sorry. Describe tables, and we can check these PetClinic owner, reference list, PetClinic vet, PetClinic pet by owner, and so on. So we work with the data. We can work both with the data from CQLSH side or from Java drivers side, as you see in our application. So what do you think, Jeff? Should we proceed to the next one?
Yeah, well, yeah, let's talk. Let me talk a little bit about Stargate, because maybe I don't want to code CQL, and maybe I don't want to have to use a driver.
You don't like CQL? How could you? That's
I like
fine.
CQL, but hypothetically, what if I didn't?
Yeah,
What if I
indeed.
want to go faster, Alex?
Yeah,
I can code faster to a REST API than I can code to CQL.
yes, sometimes you need to have full access, direct access to Cassandra and use all the power of a SQL. But sometimes you need something simpler, and sometimes you don't want your developers spend time learning SQL. You just need something right now. And Stargate is the way to give people ability to use multiple different APIs while while getting benefits from all the Cassandra, all what Cassandra features: high availability, disaster tolerance, and so on and so forth, and so on and so forth, but using much easier ways to access it. So I'm giving microphone to you, and your screen is live.
There we go. I love this astronaut character.
Definitely.
Stargate.io is the website where this project is hosted. So this is a separate open source project that we're also sponsoring. And so it's a companion project to K8ssandra, and it can be deployed independently. So if you're just running a Cassandra cluster, you can deploy Stargate with it. It does not only work in K8ssandra, but we have provided it integrated. So the value proposition here is something that we've talked and joked about already. Uh, Developers want to move fast, and they can oftentimes code more quickly to an API than they can to a query language. On the other side of things, we're hearing from a lot of SRE and DBA types who are creating abstraction layers on top of databases. So we've seen a number of companies that have created their own API layers that hide details of the database. And so they are really liking this idea of Stargate as a quick way to provide out these APIs against an existing Cassandra database. So the architecture of this is fairly simple. It's a pluggable architecture. So on the front end of Stargate, you can plug in these different APIs for interacting with data. So far, there's a REST API, a GraphQL API, and a document API, which is a flavor of a RESTful API that works in terms of JSON documents. We're working on connectors as well for Kafka and Pulsar, so you'll be able to do streaming. And then it already natively supports CQL. So the idea is you can have Stargate as a single entry point, provide a classic CQL interface as well as new APIs. On the back end, we can plug in basically anything that can talk CQL right now. So Cassandra 3.11, Cassandra 4.0 beta or release candidate, DataStax Enterprise, our Astra database as a service, really whatever. And then it integrates nicely with different authentication providers. So whatever you might be using, there are different plugins available for that. So before we talk about it anymore, I'll come back in a couple minutes and give you a little bit more details about some of the APIs, but let's do an exercise where we dive into one of the APIs in particular. And Alex is going to walk us through that.
Yep. Okay, so next point. Let me switch. Yep. So the idea is very, very simple. Be able to do more by paying lesser price. And that's what I enjoy. Well then, what do we have from the Stargate side? Let me show you some things. How do we use that? Here we go. So, Stargate is an API gateway. So first thing we need to do to access it is to grab the token, access token we need to reach to be able to communicate and to access the data. So First one, we will need password and username. Username I know already, and password, let me refresh. Where is it? I just received password, I believe, but okay. I have to get it back again, I'm sorry. Yeah, that is my password. So, oops, good. So, first one is to grab my access token. I'm executing a simple curl command with very simple sequence. So what's going on here? I need to execute a API call, simple HTTP call. It will be a post one. Okay, I have to update my address, and content type will be application JSON. So I will have header here, and data I sent will be username K8ssandra super user, and password I will use today. It goes to auth API, authentication API, so I will get my token based on that. And what I need to put here, username is already here. Now I have to put my password. Oops, my God, sorry. I have to put my password. I forgot what my buffer was here overwritten. Good. Yeah, so password is here, and now I need to put the proper address. So if you use localhost, therefore address will be a localhost for you, and if you are using cloud instance, it will be something like that. Okay, now it looks good to me. Okay, cannot achieve consistency level 1. Let me see what's going on with this cluster. Get pods, something. No, actually that is wrong, because both are running. That means what consistency level 1 must be achievable. Okay. So something is wrong on my setup. Cannot achieve consistency level 1.
Yeah, something must not have initialized. I suspect the Stargate node didn't initialize properly. Seen that once before.
Get pods. So Stargate as it is running, and those are running. Okay, that's a live demo, not a recorded one. So shit happens sometimes. What I'm going to do now basically is I will switch. I always have a plan B. So what I'm going to do right now is I'm going to open the next deployment untouched and use a fresh deployment, which should be good. And my password is here very well. So ES2 user, password. Here we go. Now, I still have to update my K8ssandra one, because this one will use new address. So some minor changes. I will update. Oops, I will update Reaper. Then I don't need actually Prometheus and Grafana for this one, so it will be fine to proceed without them. And therefore I can say helm install K8ssandra K8ssandra /K8ssandra using configuration file K8ssandra YAML. So helm install K8ssandra. Jeff, I think we need to add a couple of more K8ssandras here.
Do you think maybe you can throw those in the comments?
Oh, Yep.
Yeah.
Of course, I forgot to install the Helm here. So not install Helm, but to set up, to execute proper steps, I have to first add repository. My bad. Boom. And it will need some traffic. Boom. And I have to do Helm repo update. Boom. Well, and we go, okay, so this one, and finally I can install Helm repo update. I believe I did already, but okay. Okay, now it looks better.
Yeah.
So now Helm installed. I'm not sure what's going on here. Can add K8ssandra. Okay, it looks like I didn't execute command to add.
You didn't have the traffic repo.
Yeah, I don't have the traffic repo. Okay, makes sense. Now I finally can install traffic.
It's like a test.
Yeah,
We're testing our audience here.
yeah, and
Which command did Alex miss?
I hope you follow that and you suggesting commands to silly me.
Yeah,
together with
some
Jeff.
of our friends out there. Yep.
Ah, okay, cool, great. So Helm install K8ssandra, 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 K8ssandra. Oh, I know. I will rename configuration file from just K8ssandra YAML to K8ssandra, K8ssandra, K8ssandra YAML. When it will be K8ssandra,
Oh my
K8ssandra,
gosh.
K8ssandra,
You
K8ssandra,
just have to
K8ssandra,
make it
K8ssandra.
stop.
Well. It's never too much of K8ssandra. Okay, so deployment takes time. And I'm going, okay, this one looks good. So now I can grab my password finally. So working with data, I will need to grab my password, and that's my password will be. Boom, very well. So I guess K8ssandra and Stargate didn't start yet, but I will proceed and explain you some things. So I need to get a token, but as long as our nodes aren't operational, get box. Okay, so stateful set 0 is being started and Stargate is being started, which very makes sense. I cannot show you Stargate without Stargate being launched. So what do you think, Jeff, if maybe we postpone Stargate a little bit and do others? We still have backup
let's
and
come
repairs.
back. We'll come back to that later on and maybe do it at the end. We'll give it some time to start up. That sounds good. Why don't you give me back slide control and we'll go to that.
One sec. Boom, you are good. You are on the screen with your screen.
So here's a little bit of a sneak preview of what's available from each of these APIs. So the REST API in Stargate, you can either expose a CQL schema that you already have in your Cassandra database, and you can access it to add rows of data, to do queries, to get data back out. The API also allows you to define schema. So I can actually make REST calls and add new tables into my Cassandra database. So this is definitely a popular API. Lots of developers are very comfortable working with RESTful APIs, and you see the cool Swagger integration that's available here. One of the emerging APIs that's starting to get a lot of traction is GraphQL. And one of the really powerful things about GraphQL is the capability that it gives you to aggregate data from multiple microservices. So we're allowing you to get data from multiple Cassandra tables, for example, through GraphQL APIs. You get a little bit more fine-grained control of what are the fields that are returned. So instead of getting back the like in CQL, I could ask for the columns that I want, which is great. But in the REST API, when I ask for a row of data, I get back a JSON payload that represents, you know, the entire contents of that row. Maybe I don't necessarily want all of the contents of that row or every column in that row for my query. So GraphQL allows me as a client to specify which of the fields that I want back. We're working a lot with Apollo GraphQL on some cool integrations here and being able to do access with GraphQL APIs. And we've done some work to integrate the GraphQL playground that Apollo has. So that's something that could be demonstrated as well, and hopefully we'll get a video up on YouTube for that soon. And the third API is the document API. This is a RESTful API as well, but you're interacting in terms of documents. And what is super powerful about this is instead of having to find a CQL schema and have your table structure defined beforehand, you could just throw arbitrary JSON documents at this API. So you create collections, and then you could put whatever documents that you want into a collection and then query them back out. So there's a cool blog post on the Stargate site that talks about how this is managed, how your JSON document gets kind of carved up and stored behind the scenes on a Cassandra cluster. If you're into that sort of thing, it's a pretty cool read. But it's very powerful to be able to just store whatever document you want in Cassandra. Something that people have been asking for years as a Cassandra feature, and it's now available in Stargate. So as Alex mentioned, we're going to try to come back to that Stargate demo later on after we let everything settle down on his cluster. But let's talk about some more operational tasks. Just because you're running things in Kubernetes doesn't mean that you don't have business requirements and, you know, lifecycle requirements for your business about having backup of your data. So we're going to look at what this looks like in a K8ssandra cluster to back up the contents of your Cassandra databases to an external source like an S3 bucket.
Okay, so backup. Well, then that's something interesting. We are going to see some medusas. Do you like to swim in the sea, Jeff?
I don't know. I have a mixed opinion on that. I stay pretty close to the shore.
Yeah, but you know, usually when you see some medusas in the sea, you feel not really excited about that. You have to stop swimming and maybe quit this territory and so go to the beach or on board, and that's not so exciting. But not in this case, because in this case, Medusa is your best friend. So what we are going to do with Medusa is pretty interesting. Medusa is a component of K8ssandra. Well, actually, it's a standalone project, which we need to follow them to keep the data safe. Again, Cassandra is disaster tolerant. If you have multiple data centers, you can survive basically an earthquake destroying your data center. Your data will be available in other data centers. So it's fine. But how can you save some things in case of some developer made a mistake and destroyed a table, or maybe something happened what corrupted the data from the program point of view and you need to fall back to the yesterday state? We do it with Medusa. So Medusa supports multiple backends to store your files. One of the most widely used was for Medusa AWS S3, but we don't want you to go directly to S3, of course, and we will suggest in this case we will use Minio. Actually, Jeff, how do I pronounce that? Min.io? Minio?
I say Minio. I'm
Minio.
not positive. We will have to get together with them and ask. I would love to do a joint workshop with them, to be honest. So
Absolutely,
we'll have
it
to
sounds
see.
great. Okay, so I will, for today, I will say Minio. Maybe it's wrong, then I ask for forgiveness from all Minio team or Min.io. So let's do some backups. For this one, we will use a S8 Minion, and that's an S3 compatible backend, very convenient one, very oftenly used on Kubernetes. So first thing we have to do is to add the repository. You will see, we are going to install it, and we will see how easy it is again using Helm. So this command must be familiar to you already. Helm repo add minio, and which repository do we use to add this one? When I'm going to do Helm repo update, good, and we've got some updates. Now I'm going to install it. So let's take a look at the task I will execute. It's going to be Helm install, so you know how it works already, and I will set some settings. Access with minio k, a secret k minio secret, basically username and password. We will use default bucket enabled. Default bucket name will be K8ssandra Medusa. Name of this installation will be minio, and we will use minio as the source of truth for this one, and we will create namespace name at minio to keep things separated. So I will use K8ssandra in one key space and minio in another key space, just for clarity. So while Helm is doing some job for me, I want to see what's going on in my system. So if I do, okay, so looks like it's deployed. I can, oops, I can take a look on what's going on here. And basically it's ready. So I have pod minimum 1 running very fresh, especially for you, and service minio with cluster IP blah blah blah, deployments and replica sets, so all the normal things for an application deployed in Kubernetes. Must look pretty familiar to you. Then as the next part, we will have to add Medusa. By default, Medusa is not installed with Kubernetes because maybe you don't need that. Maybe you don't, it's a staging environment and you don't need backups or whatever. So by default, it's not installed. So we are going to install it right now. First thing we need to do is to add, as it explained in the documentation for the workshop, secret. So our systems will be able to communicate with Minion. What I'm doing right now is I'm creating a file, Medusa secret, medusa-secret.yaml, and oops, it's definitely the wrong way. Okay. I have no idea why it's not being pasted in the normal way. Not a big deal. Last time it was working fine with Medusa secret using Nano. Have no idea why it doesn't work now, but it's fine. As what's going on here? I really have no idea. It is weird, but okay. So kind secret, metadata, name, Medusa bucket key, type opaque, string, oops, it doesn't belong to metadata, string data here. Then we don't need this one, blah 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 blah, and we go to Medusa as free credentials. Yep, good. Like, really curious why it's not being formatted. To me, Medusa's free credentials. Good. Default. Okay, so now this secret file looks like it should be. Looks like. Let's try to apply that. Anyway, Kubernetes will tell me what is wrong if it's wrong. Okay, secret created, so mostly probably now it's all good. We are able to see this one. Okay, namespace, it's a wrong namespace. Okay, and we have a lot of those, and of course we have mine here. Now, we will need to change something in the K8ssandra YAML file, and I hope this part will behave good. I'm adding new section. Amazing. What the hell? I did it 3 times today. It was all good.
You're really good with indentation.
Yeah, but I mean, like, what the hell? Why it happened at all? Why it was fine just 2 hours ago? But okay, not important, as long as it will work. I don't care too much. Sorry for the little delay. Okay, bucket name. Okay, bucket name stays at this level of indentation, and storage secret is here. Let me check for spaces, because I bet there are some spaces. Yeah. Not sure if it will matter, but I better clean them up. Oops, true. Okay, now it looks good to me. And what I'm going to do now is quit and write. Okay, may have stayed in Vim. No changes, still doesn't work. Now, I'm going to what? Upgrade deployment. So, we've seen this command already. Helm upgrade K8ssandra, 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 K8ssandra. Very well. So K8ssandra has been upgraded. Happy helming revision 2. I'm using a new instance, don't forget, so that's why it's revision 2, not revision 4. And what's going on inside? We may take a look. Watch kubectl get pods. Yes. So to execute your backups, you need to have Medusa agent running alongside your Cassandra pod. Inside that, so you're going to have 3 containers in pod, as I promised. And it takes some time to recreate. It's a rolling update, so on production it leads to 0 downtime. It doesn't lead to the downtime. In my case, on the training node with a single instance, you basically have some time to wait. While it's being updated, I will prepare something for our further operations. First thing I need to have is the username as a variable. So I will execute already familiar command to you, get secret username, but this time I will load it to a variable. If you are not so familiar with bash, it may look a little bit weird to you, but it's fine, it's a bash. Don't worry. And the same for password. So now I can take a look at the user. Good, and I can take a look at the password. Good, they all are here. Now, hopefully my pod Okay, this one. Okay, it's starting. So now you see what we are expecting for 3 containers within a single pod. So one for Cassandra by itself, one for API management, and one for Medusa. While it starts, what I'm going to do next. First one, I will create some test data. So I will log into K8ssandra, I will log into Cassandra, as you've seen before already, working with SQL. I will put a couple of lines of code there. Well, not code, but some insert some rows. And finally, I will wipe it out. I will create the backup. I will wipe out all the data and I will recover backup. So we will see how it goes one by one. So I guess Cassandra is almost ready. Medusa and API management tools are running already. Last few seconds. How it goes, Jeff? Maybe we have some good questions meanwhile.
We have had some good questions. A lot of them have been answered in the chat. Some people who are asking about the workshop recording. It is going to be, we are streaming on YouTube right now, and it will be available afterward.
Using the same link.
Yes. Another thing that I think is great is I appreciate people that when you run into problems have been reporting them to us and working with us in chat. We actually have 3 new issues on the GitHub projects just from today's workshop of things that people discovered working in different environments. This is great signal for us and it's super helpful. So we really appreciate that.
Okay. So, hey, looks like it's all good and we can proceed. Well then, now I'm jumping into K8ssandra. Yes, we are good. And I'm going to load some data. So what we will do? We will create a key space Medusa test. Created. So creating key space Medusa test with replication. Simple strategy, replication factor. Do not use simple strategy on your production clusters. It's a bad idea. It's only for testing development purposes. When I'm going to attach to this key space, we are good. And finally, I'm going to create a table. So create table users, email, name, state, doesn't really matter, just temporary data. And then finally, I load some inserts into this table. So now I can say select all from Medusa test users. Boom. I don't know why it's so great, so it's hard to see. But the trap is 4 rows are loaded. And now it's time for me to run a backup. So you will love, but it's also done via command helm install.
Nice.
Yeah, so we are using familiar commands. And helm install will create a backup for us. So once again, helm install, name of the backup, what it will be, what kind it will be, K8ssandra backup, and then setting some variables. Name will be backup 1, and K8ssandra data center name is DC1, so we are working with data center 1. Execute. Now, that's an asynchronous operation, so terminal is back hours, but is the command done yet? Not yet. So I will do some watch here with, oh, okay, of course. Wrong key space. Good. And now, if we see this date and time, it means if we see this one, backup is executed already. So finish time is this one. It was pretty quick. Well, not so much work for 4 lines of data. But anyway, backup is done.
That backs up pretty fast.
Yeah.
Yeah, cool.
When you have like a couple of petabytes, it may take a little bit longer. Well, so now I'm going to do something very, very, very bad.
Uh-oh.
Do you want me to delete this data? Because that's what I'm going to do. I'm going to delete this data.
That sounds like something someone may have made you by accident.
Yeah, you know, at this moment I have to enable my Russian accent, which is strong enough as it is. But when I'm going to delete your data, I have to intensify it. So now, now I am going to delete your data. Okay, and you know what? There is nothing left. So we can get back again, select all from Medusa test users. And it's empty. All the data has been deleted.
Yep.
All your base belong to us, I would say, even say. Good. So now when it's cleaned up, it's getting to the more complex scenario when we have to recover this backup. And guess what? Which command I'm going to use? Correct. It's going to be something like helm install. You are right. So I'm going to do now helm install restore test from K8ssandra restore with some variables. Name will be restore backup 1. Backup name will be, as you could guess, backup 1 from the last backup. And data center still will be data center 1. Well, it's the only data center I have. So I'm going to execute this one. Looks good to me, but it's of course takes some time, and now it takes longer than the backup because it requires actually much more operations. So now I'm launching this watch, and I'm going to do this long path. What I'm looking is status. Oh, of course. Sorry. Yep. Good. So far, we have only restore key. So it's getting ready, but it's not executed yet. It will take a couple of more minutes to prepare things. First thing will appear is a start time. When we will have here restore key and start time, it means what procedure has started. And when finally we will have a key finish time, it will mean what operation is complete. And at this point, I will be able to attach to Cassandra and take a look how it goes with my rows. So if you want to have a 1 minute break, maybe you can take this 1 minute right now because we need 1 minute to wait for this one to be executed.
Well, why don't we come back in a second? I have a couple of slides that I want to share.
Sure. That actually sounds better to me. So I will stay here and watch for the recovery process for you. And when it will be done, I will let you know.
Okay, that sounds great.
And give me a second. Boom. So, Jeff, you alive?
Yeah. So, well, we have another unit on repairs in Cassandra that we can do. We're going to leave that one for you to do on your own after the workshop. It is something that we have demonstrated in past workshops. So we wanted to give the time today to the backup and restore because we haven't, this is the first time we're showing that in a workshop. So we really emphasize that time today. So we'll come back and Alex will come back and look at the that restore once it's done. I wanted to remind you of a few things because really we're building a community around the K8ssandra project. There's a community of like-minded individuals that are very interested in running Cassandra on Kubernetes and having a scalable data layer that's cloud native that we can run, that's very simple. And you're helping us to get there with the issues that you identified today. And we would love to have you continue to be engaged with us. If you go to the K8ssandra.io site, you can sign up for the newsletter there. You can join into the forum. Eric Ramirez, one of our colleagues, has been participating and helping answer questions today and directing some of the conversation to the forum. So he's already got forum posts up and responding to some of those questions we've been raised today. A number of you have already joined up on our Discord server, so we've been answering questions there if you need live chat support. And then make sure that you go to GitHub and star any of the projects under the K8ssandra organization, or if you might want to clone some of them. You might end up cloning the main K8ssandra repo for doing some local installation, this kind of thing. So we want to have that interaction with you. We're here to help and to answer questions that you have. Something else that has just come out is on our DataStax site, datastacks.com/dev. We have certifications, and we've been offering these certifications for several years for developers and administrators. And we have a new certification that we just launched. We announced this at the last KubeCon, the North America KubeCon last fall, that we wanted to have K8ssandra on Kubernetes certification. So we put a lot of effort into that over the past couple of months so that we could have it ready for this KubeCon. And we just launched it last week. So you can get a free voucher if you go through the course on datastacks.com/dev, which will get you smart on running Cassandra in Docker and Kubernetes, and then take you all the way through K8ssandra and the kind of things that we were doing today. And then there's an exam based on that, and you can get this certification and be one of the first people to say that you are certified to run Cassandra on Kubernetes, which I think is pretty awesome to be like in that first group of folks.
Yep, and yeah, that's indeed a great chance to be one of the very few people certified to run Cassandra on Kubernetes right now.
So as we said, you're going to be able to see the YouTube recording of this after at the same link that we shared before. We're also, if we didn't get all your questions answered today, we really tried, but maybe after the workshop you think of more. You can always hit us up on the Discord server or post a question on the forum. We're also having office hours tomorrow. So Patrick McFadden and Chris Bradford are going to be joining us as well, but at 1600 European time. We're going to be in the DataStax booth. You've seen the link here on the slide, and we can maybe get that pasted into the chat if you are interested in coming to office hours, hanging out with us, asking your tough questions. We like stumpers. We'll take them.
Yep. So, sounds great. And how it goes at my side, maybe... Now it's done. Let me take a look. So it started already, which is good.
Okay.
But not yet complete, I'm sorry. Meanwhile, there is a discussion on YouTube chat. So it would be nice to have a user interface like Reaper has to deal with backups and restores. And many people second that.
Yeah.
But you know what? It's called open source. So if you want to have something what doesn't exist, you are very welcome to go and make distributions. And just in this particular moment of time, we have got finish time. So...
yeah, take it back and show it.
Yeah, so I'm switching back to my display. Boom. And now we see all the components of the status of the executed restore. We have restore key from the beginning. You've seen this one already. Start time appeared. And now finally finish time appeared. So recovery is a more complicated process. But now it's done. We can finally check. I didn't touch this interface. I didn't touch this instance. So no cheating. It was really recovered. But let's us finally check it on our own. So first I'm going to jump into the node. Second, I'm going to use Medusa test. And finally, I'm going to select all from Medusa test users, which is correct. And here are our heroes: Alice Smith, Bob Jones, David Young, and Carol Jackson.
Got it back.
Yeah,
Right.
Texas, North Virginia, California, and so on. Or NV, what does it stand for? North?
Nevada.
Nevada, oh, Nevada, okay.
Home of Las Vegas.
Okay, I'm not so good in the United States geography. Maybe for good. So,
you know, next time maybe it should be the Menti quiz winners that we put into this table.
that really makes sense. We have to put them next time. That's a good idea. So, backup restore are done, and I have just last few seconds to say a word about the repairs. Don't you mind?
I don't think we have time for that, honestly.
We have 5 more minutes and
well,
slides.
Did you want to? So this is our last minute negotiation here. Last minute workshop negotiation. Did you want to say anything about the Menti or for the feedback, or is that already done?
Menti feedback is done already, so let me check. We are getting tons of feedback, and thank you so much for answering. So there are some dozens of thank you or improvements or some ideas. Streaming with Kafka and Pulsar APIs.
Oh yeah, I want that. Yeah.
We are launching Pulsar streaming series soon as a part of DataStax Monday Learning. It will be not a workshop. It's something better. It will be 3 episode series dedicated to event streaming and Pulsar. So it will be amazing. We start in the end of May on Mondays. 3 series. So thank you for word feedback.
Let's do it.
Yeah, and
we can do repairs. I think we'll treat this as bonus content. We can keep going. If you you've been with us for 3 hours, if your brain is full and you're ready to go, bless you. Thanks for joining us. And if you have a couple extra minutes, Alex is going to show us the repair demo.
Yeah, but there is not too much to show. So repairs are very important. As as it was very well said by Vinay Kumarchella from Netflix cloud database architect, I believe. It was without repairs, your database is hopefully consistent. This definition, hopefully consistent, it's like a really great one. Yeah. So we need to run repairs to check if all the data is consistent over multiple nodes or data centers. And I have my simple K8ssandra cluster, and that's important to run repair on a scheduled basis, on a regular schedule, on some cadence. And I want just to start a new repair, but I don't want to do it. The first thing I want to do is to go to the schedules and add a new schedule or schedule. You say schedule. Yeah, I believe so. Schedule. Thank you.
In UK, you might say schedule.
Okay.
So international variations aside.
Well, you see, I speak German, and this first SCH looks like really German sh to me. So yeah, okay. So first I have to select a cluster I'm going to repair. I don't have a lot of choice because I have only one. The next one is going to be key space, and I will work with Spring Pet Clinic, for example. Then owner, it's me, Alex. And what's the start time and what's the cadence? I will set it weekly. And I can add this schedule. Okay. And I will add this schedule. And actually, I don't want to wait for 7 days because next run is scheduled for 7 days. I will push the button right now. And I have a notification what repair run will start shortly. Why? And I can switch them to the superhero. That's quite interesting, but doesn't switch to me. Doesn't matter. So repairs, or better say schedules. I have this schedule. I pushed the run now button so we can proceed to repair. And we see it in running field already. So we see when it started, approximate time of the end, status, cluster, key space, how many tables we are going to do, and we can push the button and view segments. So which ranges, which segments it's taking care of. you maybe know what Cassandra takes care of ranges of tokens. So every node is responsible for a token range, and smoothly, range by range, it takes every range, executes the check. Fail count is 0, which value is pretty obvious in this case, and marks them as executed. And just as we look at that, we see what next segment has been executed, checked, verified, and in the state done. No inconsistencies, which is quite understandable for a test cluster. And it's going to have some time, but we will not wait till the end, because the main idea is simple. That's very important for you to have it on a regular basis. And that's very important for you to understand how Cassandra and K8ssandra works. The point is, that's a complex distributed system, so that's pretty easy to shoot in your own leg. But if you want to avoid that, DataStax has you covered. With the free courses at the academy.datastax.com, and with such a lot of content at datastax.com/dev, and with free sponsored certification. This certification is not free, we pay for it, but it's a sponsored certification by DataStax. You can become now a qualified Apache Cassandra expert as a developer, administrator, or Kubernetes administrator, or all of them, like catch them all, with no costs at all. So actually, that's my favorite part of the work. I love to see how people getting their certifications, how people are getting better salaries, jobs, or maybe staying at the same place, but with more just understanding better what we are doing and how it works. That's amazing.
Yeah. Well, why don't you put the last slide up?
Yep.
And it just it's the slide with our contact information. So if you want to reach out and get connected with us, we'd love to hear from you. And we even put the Calendly link on there. So if you have some more detailed questions and would like to grab 30 minutes on the calendar, then move our little heads around so we're not blocking things. There you go. We're pretty easy to find on whatever platform that you're on. So that's really our content for today. Is there anything else that we should say, Alex?
I think we are done, and we even a little bit over time. So it's a good moment to stop and just invite you to the next events we are doing. At the DataStax developers, we run weekly workshops. So we will be here, or sometimes even 2 times per week, as it will be with Pulsar series, event streaming series. So we definitely will see you again. Thank you for joining us today.
Thanks a lot. Have a good night.
And that was incredible experience, and thank you for your questions. Have a great time.